Template literals, once referred to as template strings, are a special type of string that come with an extra set of features. One of the most common features of template literals is string interpolation, where you can embed values or expressions directly into your string. So instead of performing string concatenation, which is the use of plus signs to incorporate variables, as you can see here in this example, I have my method greeting where I return a string that's built using those plus signs. I can do something like this instead, where I can directly inject values into my string while not having to perform the mental work of keeping track of spacing between strings and my inserted values. But there's a lot more to template literals than just embedding values, and we'll explore all those features in this video. What's up, I'm Gemma, and today in this video we're going to be taking a closer look at template literals. We're going to understand the benefits that template literals bring to the table when compared to regular string literals. On top of that, we'll learn how to use them and walk through some real use cases so you can feel more comfortable using them in your own projects. So let's dive into template literals. Template literals are special such that they come with an extra set of features that don't live on a regular string. But before we jump into any of those special features, let's take a second to create a super basic template literal. Here we have three variables: first name, last name, and full name, where first name and last name are regular strings, while full name is our template literal. We know full name is a template literal because it's created using the backtick character, unlike regular strings that use either double or single quotes. So a template literal will always use the backtick syntax. Cool, so now that we know how to create a template literal and we know what it looks like, let's take a look at some of its features. One of template literal's most commonly used feature is string interpolation. As I showed you in the beginning of this video, string interpolation is a popular alternative to string concatenation. More specifically, string interpolation allows you to directly embed or inject expressions directly inside of your template literal. In order for injected variables to be converted over to their expressions in the final string, we have to use a special syntax $ curly braces so JavaScript knows to replace the variable names with their actual expressions. So in this code block, we can see that for my full name string, I'm embedding the first name and last name variables inside of it. Again, for me to be able to do that, I have to wrap my variables inside a $ and curly braces, so JavaScript knows that an expression value is being injected. One of the biggest benefits of using string interpolation is that it's so much easier creating dynamic strings when compared to string concatenation. So as you can see in this code block, I have my full name and my concat name, where full name is using string interpolation while concat name is using string concatenation. One of the hardest things to deal with when using string concatenation is having to watch out for the right spacing. Oftentimes when I'm using string concatenation, I forget to add a space and my final string just looks a little off. That problem is addressed nicely with the use of string interpolation. And just like string concatenation, you can insert any type of value that can be coerced into a string type with string interpolation. So here you can see I created a new artist object with first name, last name, and age, where age is specifically a big int instead of a regular number. In my final sentence, you can see that I'm embedding my artist's first name, last name, and age. And you can see that my final sentence is Stevie Wonder is 70 years old. Notice how the N in 70 gets dropped. This happens because when a big int gets coerced into a string, it drops the letter N. It's also important to note that although template literals are interpreted just like regular strings in JavaScript, there are popular style guides out there like Airbnb's that says that creating a template literal without embedding any expression should be considered an error. So here in this Airbnb code block example, you can see that creating a string with double quotes is considered bad. You can also see that creating a string with a template literal with no string interpolation is also considered bad. So it's pretty important to keep in mind that if you're ever using a template literal, try to use a template literal for its features and not just for a plain vanilla string. The next unique template literal feature is multi-line strings. So you can see in this code block, I can open my template literal with a backtick and type some text, press enter, and continue my string with no problem. Specifically for this code block, I'm writing out some DOM literals inside a string, which I can then use later on to write another HTML file. This comes in handy if you want to have control over creating DOM elements inside of your JavaScript files. But again, this multi-line feature only works with template literals. So if you try to create a multi-line string with a regular literal, you'll get a syntax error. With regular strings, you'll have to use the escaped new line character, which is a /n, to achieve the same multi-line effect that we see come straight out of the box from template literals. So you can see with my DOM elements string, there's tons of /n's to denote that I'm trying to create a new line between each of my DOM elements. But you can already tell from this code that it's already getting difficult to parse and read through this string. And the last and probably least well-known but most interesting template literal feature is the tag template literal. A tag template literal is a template literal that gets passed into a function where the arguments that are exposed inside of that said function are the parsed out string literals and embedded expressions. Let me show you what this looks like. You can see here that I have my function tag. Inside the tag method, I have two arguments, which are my literals and my expressions. The literals argument is an array containing all of my spliced string literals that come from my template literal. And my expressions argument is all of my rested embedded expressions that come from the template literal, and they're all contained in one array. So if we print out the literals and expressions array, we should see all of our string literals in one array and all of our embedded expressions in another array. And lastly, whatever gets returned from our tag method is the final string that's returned from our tagged template literal. So at the bottom of my code block, my tag template literal is the entire line of tag my name is with my first name and last name being embedded. If I printed out this tag template literal, I'll get nothing since my tag function is not returning anything. So if I updated my tag method where I'm returning random string, it doesn't matter what string literals or expressions I pass into my tag function, I'm always going to get random string as a result from my tag template literal. So with my tag template literal now being assigned to new string, if I print out new string, I should always just see random string as a result. So this shows that we have complete control over what gets returned from a tag template literal, but let's say that you want to actually construct the expected tag template literal inside of your tag function. So inside my tag method, I first define my empty string variable, and right after that, I call for each on my literals array. For each literal, I want to append it to the final string along with my current expression. There can also be a chance where an expression may not exist at the current index, so to make sure that I don't get any undefined in my final string, I'll file back on an empty string, as you can see here with the double pipe sign. And then I'll return out my final string, so you can see here that my new string at the very bottom is my name is Stevie Wonder, what I expect from my template literal. So now that we're getting a better understanding of how tag template literals work, we need to answer the more important questions of why and when. Why should we use tag template literals and when should we use them? One of the main benefits that comes from using tag template literals is that you have complete control over what gets created from passing in a set of string literals and embedded expressions. Since our tag function gets all of our string literals and embedded expressions, we can take that information and do whatever we want with it. We can create another object, another function, or another string. It's all up to us inside of our tag template literal function. Let's say that you wanted to bold each embedded expression inside of your template literal. How would you go about doing that? If we didn't want to use tag template literals, we could do something like this. So what I'm doing here is gathering all my expressions that I want to be wrapped in a strong tag and placing them inside of a temporary anonymous array. I'll map over that array and place the strong tags around each name and create a new names array. Then once I'm done with that, I have to individually index into my names array to insert each name into my final string. This logic feels a little too separate and all over the place, and maybe with a little bit extra time refactoring, I can make this solution a little bit cleaner, but with tag template literals, the solution is so much nicer. So here I have a new function called bold expressions that takes in my strings and expressions. Inside this method, I'm stepping through each of my strings and then appending the corresponding expressions by wrapping it inside of strong tags. I then return the string at the very end of our bold expressions method. So when I create a new tag template literal, my final string should have strong tags wrapped around each of my variable values. All the logic resided in one function, making it easier to keep track of what the responsibility of bold expressions is. If I wanted to get a little bit more succinct with my code, I could use reduce. So in this code block, I'm calling the reduce method on my strings array, and what reduce is doing is stepping through each of my strings and then appending the next embedded expression, which is wrapped in its own strong tags. I then return this reduce method call since it's going to return back to us our final string. So through this example, I wanted to show you that you have a lot of control over how you can interact with each individual embedded expression inside of a tag template literal. Another popular use case of tag template literals is using styled components, which allows for CSS in JavaScript. This next code block is going to have a little bit of React, but the idea of tag template literals is still present. In this code block, we can see that we're using a tag template literal to actually create a React component called button, which we can later render into the DOM. Our tag function is style button, which will take in our template literal, parse out the string literals from my embedded expressions, which are the blue variables, and then use that information to create a whole new React component that's following those styles. So we can see here that our styled button is under the hood just creating a whole new object, even though it's passed in some strings and some expressions. So creating React components from tag template literals gives a lot more freedom to developers such that they can define more dynamic or conditional CSS inside of their JavaScript. Instead of creating multiple classes inside of your CSS files and then conditionally applying those different classes inside of your JavaScript files, you can just create styled components that exposes your CSS inside of your JavaScript. By exposing your CSS in your JavaScript, you have more freedom and flexibility and a little bit more nuance on what you want to conditionally change depending on your application state. These are just some popular use cases, but there's probably a ton more use cases out there, so let me know if there's one popular use case that you've used before or seen before. Hopefully by the end of this video, you can see that tag template literals are just a jacked up version of regular string literals, and they provide a lot of flexibility when it comes to creating not only strings, but functions or components or objects. But tell me what you think. Is this the first time you've ever heard of template literals or tag template literals, or have you been using it for a minute in your projects? But that's it for this video. If you watched up until this point, thank you so much. If you enjoyed this video, you can drop a like and subscribe to the channel for more content. If there's any specific topic that you want me to cover in the future, let me know down in the comment section below. I'm also on Twitter where I talk about JavaScript and a wide variety of different things. You can feel free to send me a DM so we can have a chat. And with that, I'll see you all in the next one.